Hello everyone and welcome back to Mastermind e-learning. In today's video, we are going to learn about congruence of triangles and the different tests of congruency. So let's get started. What is congruence? In mathematics, congruence means having the same shape and size. Congruent objects are exact copies of one another. Now look at these two line segments, AB and CD. They have the same length and they are exactly copies of one another. Two line segments AB and CD are congruent if they have equal lengths. And we write this as AB is congruent to CD. This is the symbol of congruence. Now look at these angles, angle ABC and angle PQR. They are also identical. Now, angles are measured in degrees. So, if these angles have equal measures, then they are said to be congruent. So, we say that two angles ABC and angle PQR are congruent if they have equal measures. Now, look at these two triangles. If you observe them, they are identical. Now, if you try to superimpose one triangle over the other, they will exactly superimpose. So you saw that the orange triangle exactly superimposed the yellow one. So these triangles are said to be congruent. Now these triangles are congruent, that means they have equal sides and equal angles. So all the sides and all the angles of these triangles are equal. So if we want to prove that two triangles are congruent, how would we prove that? We need not find out whether all the sides or all the angles are congruent, but there are some criterions for deciding whether the triangles are congruent or not. So let us learn the tests of congruency of triangles. The first test is side-side-side test or SSS test of congruence. Now look at these two triangles, triangle ABC and triangle PQR. If you observe, AB is equal to PQ. The side AB and side PQ have the same symbol. That means they both are equal. Also, we have AC is equal to PR. This side AC and side PR are equal in length. Also, we have side BC is equal to side QR. Right? So, what does this show? This shows that the three sides of one triangle are equal to the three sides of the other triangle. Now, if under a given correspondence, the three sides of one triangle are equal to the three corresponding sides of another triangle, then the triangles are congruent by SSS Congruence Test or side-side-side congruence test. Now, there's one more important thing. We also see that A corresponds to P. This arrow, the symbol here is actually corresponds to. This is read as corresponds to. That means A and P coincide with each other. B corresponds to Q and C corresponds to R. You can look at this. A and P, they correspond to each other. B and Q, they correspond to each other. C and R, they correspond to each other. So we have triangle ABC is congruent to triangle PQR. The order of the letters in the names of the congruent triangles displays the corresponding relationships. So we cannot change the order here. We cannot say that triangle ABC is congruent to triangle QPR. That will entirely change the meaning. So the order in which you write the name is very, very important in writing the symbolic way of congruence. So now let us see the next test of congruence. The side angle side test of congruence. Now look at these two triangles here. Triangle ABC and triangle PQR. We observe that AB is equal to PQ because you can see the same marking over here in both of these triangles. And then angle B is equal to angle Q. Side BC is equal to side QR. Okay, so we have one side one angle and one side equal to the side angle and side of another triangle. So what do we say? This shows that the two sides and the included angle. Now what does this included mean? The angle between the two sides. This angle B lies between the side AB and BC, and we are taking that as the included angle. That included angle, and in this triangle we have sides PQ and QR, and the included angle is angle Q. So two sides and the included angle of one triangle are equal to two sides and included angle of the other triangle. So in such a case, if we say that they are congruent under SAS Congruence Test. So let us define SAS test. If under a correspondence, two sides and the angle included between them of a triangle are equal to two corresponding sides and the angle included between them of another triangle, then the triangles are congruent by SAS Congruence Test. You will observe, look at the diagram, it will appear like this. There will be two sides and in between there would be an angle which would be marked over here. So now let's see the next test of congruency. The angle side angle test of congruence. Now look at these two triangles, triangle ABC and triangle PQR. If you observe, there are two angles which are marked. Angle B is equal to angle Q. Then there is a side BC which is equal to side QR. Next, we again talk about an angle. The angle C is equal to angle R. So what does this show? This shows that the two angles and the included side of one triangle are equal to the two angles and the included side of the other triangle. Now what does this included mean? The side lies between the two angles. It is not the third side or a side which is away from it. It is the side which lies between the two angles. So this side and the two angles of one triangle and the included side and the two angles of another triangle are equal in this case. So then in such a case, we will define the ASA Congruence Test here. If under a correspondence, two angles and the included side of a triangle are equal to the two corresponding angles and the included side of another triangle, then the triangles are congruent by ASA Congruence Test. Now we'll talk about one other type of triangle, that is the right-angled triangle. You can look at these triangles here. These both triangles are right-angled triangles. And if you look at this first triangle, the side AC is the hypotenuse of this triangle. Hypotenuse, that is the side opposite to this 90-degree angle. And in this triangle, the hypotenuse is PR. Now, what does this test say? First of all, we'll write down what we know. We observe that angle B is equal to angle Q is equal to 90 degree. And this hypotenuse AC is equal to the hypotenuse PR. Also, we can observe that this side BC is equal to the side QR. This shows that the hypotenuse and one side of this triangle are equal to the hypotenuse and the corresponding side of the other triangle. In such a case, we'll define the RHS congruence test. If under a correspondence, the hypotenuse and one side of a right-angled triangle are respectively equal to the hypotenuse and one side of another right-angled triangle, then the triangles are congruent by RHS congruence test. That is, right-angled hypotenuse side congruence test.